Okay, today's lesson is the 7th grade lesson 2.1. Students will compare fractions and decimals. They will then extend this knowledge to include repeating decimals. The standards covered in this lesson are 7NS2B and D, as well as 7EE3. The book pages that you will use are out of the hardcover book, pages 52 through 55, and out of the practice journal, pages 29 through 32. Today we're going to be working with what they call rational numbers. A rational number is any number that can be written as a ratio of two integers. So a ratio, another way of explaining a ratio would be like a fraction. So any number, whether it be a whole number, a negative whole number, or a decimal, as long as it can be written out as a fraction, then it is considered a rational number. So for example, 2 here could be written out as 2 over 1. So 2, a whole number, is considered a rational number. Negative 3, the integer of negative 3, could be written out as negative 3 over 1. So that also is an example of a rational number. So any whole number or its opposite, so all integers in other words, are considered rational numbers. A fraction obviously is already written out as a fraction. So we've got negative 1/2. Well, that could be written out as an integer of negative 1 over 2. But once again, we would look at that as 1/2. And then decimals. So some decimals are rational. There are some that are not. So a rational decimal, for example, 0.25 or 25 hundredths could be reduced down to 1/4. So if you can write the decimal as a fraction, then it would be considered a rational number. Okay, so we discussed that some decimals are going to be considered rational numbers. There are a couple different types of decimals that we're going to work with that are considered rational. One of them is called a terminating decimal. A terminating decimal is a decimal that ends. So here's some examples of terminating decimals. They have an end point. So 1.5, it just ends at the 5. Negative 0.25. So yes, there's a negative in front of that, but rational numbers can be either positive or negative. So it's a decimal that ended. 10.625 also ended after the 5, okay? So these are all examples of rational numbers, okay? Another example is a repeating decimal. So a repeating decimal is one that has a pattern that repeats, or it continues in that same pattern. So here are some examples of repeating decimals. So if we had negative 1.3333, and then these little dots mean, hey, it's continuing in that pattern forever. Well, we would write that out as negative 1.3 with the repeat end bar over the number that repeated, okay? Now, to explain why repeating numbers are considered rational, well, really, this could be written out as negative 1, and then 0.3 repeating is 1/3. And notice that 1/3 is a fraction. Okay, another example here we have is 0.151515, and once again, we have these 3 dots saying that's going to continue forever. So take note that they wrote out the final answer is 0.15 with a line over both the 1 and the 5 because they both continue to repeat. Okay, the one thing that I do want to point out is as we get into working with fractions into decimals, sometimes, and I'll kind of point this out on our next thing, is sometimes you get something that looks like it's repeating and the very end number all of a sudden changes. So we're going to discuss that out. So repeating decimals are also considered rational numbers. You could I could expect you to memorize that number of 0.151515, and you would be okay with that. We will come in contact with some numbers that are called irrational, and those are ones that never end. So like pi, for example, is considered an irrational number. And the way I always explain it to kids is if I asked you to memorize that number, you would say, I was crazy. You're crazy. It never ends. That's irrational. So irrational numbers are not considered a rational number, obviously. So those non-ending numbers, those ones that never end, would be non or irrational. These terminating and repeating are considered rational numbers because you can write them out as a ratio. Okay, so here's just a visual of what rational numbers include. And I already discussed that they include all integers. They also include all whole numbers because whole numbers are part of the integers. So You know, if you were to say whole numbers, if you count from 0 on up, those are whole numbers. Integers then include the negatives, but they're still whole, no decimal, no fraction. Rational numbers are now going to go up both sides, both directions, positive and negative, and they are going to include fractions, okay, all fractions, mixed number, or just a regular old fraction. Every fraction is considered rational. Decimals that either terminate or repeat are considered rational. Okay, so those are examples of rational numbers. Every single one of these on there is considered a rational number. Okay, so the first concept that we're going to work with today is writing fractions as decimals. So this is the part of the book where I will say, okay, you can start to use your calculator for this concept. I know that yes, we can divide this all out longhand, but right now I'm not here to frustrate you. I do want you to understand the steps that you can use to transfer 1/6 into its decimal form. And most common made mistake is kids want to just take the numbers and put a decimal in front of them. And so some kids want to just write out 1/6 as 0.16, okay? Not saying that that's not the answer, but not always is that going to happen. In this case, it does. So when I look at this, I'm going to actually look at this for the operation that it is, and that is a division sign. So when I look at this, I'm going to take and do 1 divided by 6. Now, if I was going to do that longhand, it would look like this, okay? Which I'm not going to have you do that today. We're going to work with our calculators. So when I read this fraction right here, I need to remember that I need to read it just like I do in a book. Most common made mistake is kids go through and flip their numbers around. If I start reading in a book, I start at the top of the page and I work my way down. I am going to do that same concept with this fraction. So when I punch in on my calculator, I'm going to punch 1. This is the division sign, so my divided button, and then 6. Okay, so I'll pull this out. So I've got 1 divided by 6. And I get 0.1666666 and a bunch of sixes, and all of a sudden there's a 7 at the very end. Okay, so what I need you to realize, and I can't touch my calculator because it'll move, that this last 7 on the calculator is really just the calculator rounding up the last digit. It's not saying that all of a sudden it changes. It's saying I'm rounding up the last digit. Okay, so there would have been another 6. The 6 behind that last 6 actually rounded it up to a 7. So my final answer on this would be point, and yes, you can put your 0. If you leave it off, that's okay. 1/6, and then the 6 is repeating. Okay, so we would only put the line over the 6. Okay, we're not going to put the 7 on there because really that's just my calculator rounding. And some of your calculators won't round, so you won't see that 7. But a lot of the scientific calculators round. Okay, so let's try another one. This time I'm going to give you a mixed number, and we're going to discuss out what you do when you have a mixed number and you're changing it. Okay, so here I have -2 and 1/4. So really the only step that I'm going to add to what I previously did is I'm going to take this and I'm going to write it in front of my decimal. So it's going to be a -2, and my decimal is going to sit here. Now I'm going to think of this as just a fraction of 1/4. Okay, so 1 divided by 4. Now, some of you know that in your head, but if you didn't, okay, let's just go ahead and do 1 divided by 4 just to practice that calculator skill. I get 0.25. So I'm just going to write my 0.25 here. This is my final answer. Okay, so I don't have to change -2 and 1/4 to a mixed number, or sorry, to an improper fraction. I'm just going to carry this -2 down and then work with the fraction behind it and make sure I put my answer as behind the decimal. Okay, so I'm going to pull 2 out here and have you guys practice those. Okay, so you're going to do these next 2. And yes, you can use your calculator. Jot down your answers on your whiteboard or a sheet of paper, whatever you have with you. And then, so go ahead and pause your video, get your 2 answers, and check back with me in just a minute, okay? So pause your video and do these 2. You should have gotten 0.45, both repeating, for 5/11ths. And for 1 and 5/27ths, you should have gotten 1.185 with all of these repeating. Okay, So our next step is to work with the opposite, where they're gonna go ahead and they're gonna give us the decimal, and they want us to write out the fraction. So we're gonna read the numbers behind the decimal and their place value. Now I know some kids struggle with reading place value. Okay, when you work with decimal numbers, you've got your decimal, and then this first place behind it is called the tenths. Then you have the hundredths, the thousandths, the 10,000ths, and so forth. Okay, and some kids, that throws them off right away, and they say, I'm not going to be successful at this because I can't memorize all of those. Okay, so I'm going to teach you a technique today that you can use even if you don't have all of these place values memorized. Some of you do, and that's awesome. You can go ahead and use that skill. But some of you don't, and so I don't want that to be what deters you from being successful at this concept. Okay, so the first step we're going to do is when I look at this negative 0.26, which I would read that as 26 hundredths. And those of you that can read this decimal number, well, you're really saying the fraction anyway. Okay, but let's say you weren't good and you weren't good at reading it with the place value, and all you could say is that's negative 0.26. You're going to take this number that's behind the decimal, and you're going to write it as the top number. Okay, then we're going to put our fraction bar. And then here's the trick. I'm going to count how many numbers are behind that decimal. There are 2. Take note, there are 2 zeros behind my 1 on the bottom number. So I end up with negative 26 over 100, which now, that's my first step. Now I'm going to look at this and see if I can reduce that down. And I'm noticing that these are both even numbers, which means 2 would go in both of them. So 26 divided by 2 would give me 13. And 100 divided by 2 would give me 50. That's how we ended up at the negative 13/50ths. Okay, so we're going to practice some of these skills. Okay, so here's our first one. We have negative 0.7. Now some kids can read that, and they can read it with the place value. Let's pretend like I wasn't good at that. So I'm going to go ahead and I'm going to put my negative sign out in front because I know that has to be part of my answer. I'm going to take this number, and it's going to become my top number. So it becomes a 7 as my top number. And then to figure out the bottom number, well, there was only one number behind the decimal. So I'm going to have a 1 followed by 1, 0. Okay, this will always be a 1 on the bottom until we have to reduce. Sometimes then it changes. So this is my final answer, negative 7/10. And the nice thing about this is most kids are good at reading a fraction, but not good at reading a decimal. So if they were to then ask us the next step of, could you write this out in words? Well, you could probably say negative 7/10 and write that out in words, versus up here, maybe a student couldn't do that. Okay, so let's try another one. Okay, this next one, we're going to have a number in front of our decimal. Okay, so I have negative 10.25. Okay, and when I read that, this is negative 10. This right here means and 25, and then I have to figure out the place value. Maybe I'm not great at that. Okay, so I'm going to take what's sitting in front, and that's just going to be that big in size number that sits out in the front of my fraction. So there's my negative 10. Okay, this is going to be my top number, so 25 is the top. Over, there's 1, 2 numbers, so I'm going to have a 1 with 2 zeros. So I've got negative 10 and 25 hundredths. So if I was going to write it out in words, that's how I would write it out in words. But now I have to make this in lowest terms because they're going to ask us to simplify it. Okay, so I'm noticing here and here that 5 would go into both of those, but I'm noticing a bigger number, and that would be 25. So I'm going to divide each of these by 25 in my head. And if you can't, then pull a calculator out. Final answer is negative 10. 25 divided by 25 is going to give me 1. 100 divided by 25 is going to give me 4. So I just found out that my final answer is negative 10 and 1/4. Okay? At least for now, start with this process. You know, if it's the reduction that's slowing you down, we'll work on that. We'll work on that skill. But for right now, I want you practicing converting it into a fraction. And then if we have to work on the reduction, we'll do that as we're learning it. Okay, so practice the process of changing it into a fraction first. Okay, so I'm going to pull these 2 out. And that first one, you're going to have to reduce down. Okay, so go ahead, pause your video, and work through these two, and then check back when you're finished. So write them on your whiteboard or on your sheet of paper. So go ahead and pause the video and do that now. So you should have gotten 125 thousandths, which reduces to 1/8 for the first one. And the second one is -3 and 1/10. Okay, so the last concept that we're going to be working with in this lesson is ordering rational numbers. So you'll notice here we've got some fractions and some decimals. To me, unless you're really, really comfortable with fractions, it's probably easier to go through and change any fraction that you have into its decimal form. Now, some kids are comfortable with with fractions, and they're able to go through and just think through what it would look like as a decimal or as a fraction, a mixed number or whatever, and they're able to still order them. But most kids are not. So maybe your first step is to go through and change each of these fractions into their decimal form. So we're going to go through and use what we learned at the very beginning of the lesson, and we're going to divide these out. So we'll practice once again. If I want to change 9/5 into a decimal, I'm going to do 9 divided by 5. When I do that, I get 1.8. So this I'm now going to look at as 1.8. Okay, this other fraction, well, I know there's a negative, so I'm going to put my negative in front. And then 4 divided by 5, which is 8/10, but I'll go ahead and do that on my calculator. It's 0.8. And I'm just going to put the 0.8, not the 0 in there. Okay, so now I'm going to go ahead and now look at any of my negative numbers first, because those are always going to be my smallest numbers. So I'm a visual person, so I'm going to mark my negatives in blue. Okay, so there's my negatives. So as I'm looking at those negatives, I'm going to think opposite. Remember, negatives, I have to think in terms of opposite. So if I were to look at those without the negative sign, I would say, well, 2.5 is the biggest. Well, we're working in negative, so that's the smallest. So negative 2.5 is going to sit here. Okay, so I'm done working with that one. I now would say, well, what one's bigger? If it was just the whole, or not the whole numbers, the positive numbers, I would say 1.1 is the bigger of the two that I have left there. Well, we're working negative, so the opposite, so that's going to be my next one. And then my last negative is that negative 0.8, which originally was negative and negative 4/5. So I'm going to write it out as that 4/5 there. Okay, so I'm done looking at these. I'm now left with 0.8 and 1.8. Now these are positive numbers. So now I'm going to go ahead and work off of those positive numbers. So what would be my smallest of those two numbers? Well, it would be 0.8. And then lastly, it would be 1.8, which was originally 9/5. Okay, so that's working with ordering rational numbers. Now, like I said, some kids are going to be able to go through and just work off of the fractions, but many are going to have to go through and change those fractions to decimals to be able to compare them. Okay, because if you work fractions, unless you're really good at, breaking things down, maybe seeing pictures, you have to have a common denominator to compare them. Okay, so it's a lot easier to compare decimals. Okay, so my first step, because I like to compare decimals, is I'm going to change each of these into their decimal form. So 11 divided by 5 gives me 2.2. Now there was a negative sign in front of that, so negative 2.2. Okay, and then 15/10. 15 divided by 10 is 1.5 or 1.5. All right, so there's my fractions written out. Okay, so my next step now is I need to find the ones that are the smallest. So those are always going to be my negative numbers. So I'm going to go ahead and circle those. So I'll circle them in red this time. So there's a negative, there's a negative, there's a negative. So we're going to think backwards. I want to find, if those were numbers without negative signs, what would be the biggest number? Well, 2.4 would be. So that's my smallest because it's opposite since it's negatives. Okay, so I'm done with that one. So of my 2 I have left, I have 2.2 negative and negative 2.25. Now some kids get confused when I've got the first 2 numbers the same. So here's the thing, if you need to, you can always add a 0 to the end to make it easier to compare. Now I can compare 20 behind the decimal to 25. So since we're working opposites, what would be the bigger of those 2? Well, the negative 2.25. So really that's a smaller because it's negative 2.25. So I'm done with that one. Now I have my only other negative left, which was negative 2.2, which was originally negative 11/5. Okay, done. All right, so what I have left are my 2 blue ones here. And now we're working those positive numbers. So I'm gonna go ahead and look at these and say, okay, what's smaller? 1.5 or 1.6? So I have to kind of change my thinking again. Well, 1.5 would be the smaller. Oops, what did I do wrong? I wrote out 1.5 instead of what it was originally. Originally it was 15/10. So I'm gonna write it out as 15/10. And then the last one would be 1.6. Okay, so these take time to get comfortable with. You just need to go slow and work your way through them. Change fractions to decimals. Pick out your negatives. Okay, find the number that would normally be the biggest, and since it's negatives, the biggest would be the smallest. Okay, so I want you to go through and actually do this last one. So you're gonna pause your video and you're gonna work through this one on your whiteboard or a sheet of paper, and then you can restart the video to check yourself. So go ahead and pause your video now and work through transferring these these fractions into decimals if you need to, and then arrange them in order. Okay, so that's the order that you should have ended up getting from this set of numbers. Okay, and hopefully you're going through and you're actually pausing the video and practicing it and then checking yourself. Because obviously, yes, you can get this answer, but that's not going to help you understand as you're going through and taking an assessment how to do that. Okay, so good luck with these guys. The ordering is probably the part that's the part that takes the most time. So just slow down, take your time through those.